Hello and welcome back to Build Proportion Lab at Devoxx France 2024 live from Paris. And my next guest is Mark Rendle.
Yes, hi.
Nice to meet you, Mark.
Nice to meet you.
Thank you for coming. And Mark, you told me that your talks here at Devoxx are about the history of programming and
Yes.
programming languages.
Yes,
And this is obviously a fascinating topic.
it really is. I'm doing very proud and honoured to be doing the opening keynote tomorrow, which is about programming's greatest mistakes. So things that have blown up or cost a lot of money because people got things wrong.
I think we know programming's biggest mistake,
Null.
JavaScript.
And that is what my other talk is about. My other talk is, it's called How JavaScript Happened. And if people want to read into that, how can we stop it from happening again? That's fine with me.
Yeah, no, I guess TypeScript is kind of sort of fixed it.
It's sort of helping to fix it, but
Yeah.
TypeScript, it's great for programmers to be able to say this is this kind of object and this function takes this kind of object and so on. But by the time it's running, it's just become JavaScript again, and so it still suffers from all the things that JavaScript.
No, but at least that
suffers
people
from
do a
that.
little bit less mistakes when they write code, right?
Yeah,
But yeah, you know what? Let's take it one by one. Okay, so the biggest programming mistake we kind of spoiled it is null.
I think so. In terms of what's cost the most money and caused the most problems, and the guy who invented null has basically said, I really wish I hadn't. And he calls it his billion-dollar mistake, but I think probably a lot more than that. You see null reference exceptions, you see object reference not set exceptions, all these sorts of things. It's incredibly common, and there are better ways of handling it. You have like option types and maybe types that you get from functional programming. And so, yeah, it's that's cost a lot of money.
Okay, well, that makes sense when I think about it. And all the efforts of all the modern languages to get away with, like, to kind of abstract it, because in the end of the day, when the higher level languages, when they go into runtime and do lower level languages, they will encounter null del.
Yes.
So there is no real way to get, like, to escape it. It's just a matter of how do you mask it so people won't have to deal with it all the time, but also a way to deal with it because it's still there.
Yes. So, I'm a .NET developer primarily, and the C# programming language, they introduced this idea of nullable reference types. And so you're basically saying, hey, it's a reference type, and it could be null, and then the compiler will actually complain if you don't check to make sure it's null before trying to access a property or a method or something. And you can configure the compiler to say, that's not just a warning, it's an error. And so you can stop your code from compiling. But it still requires you to put a question mark at the end of the type and that sort of thing.
Yeah, and we have that in Java. We can make the compiler to actually, so for that, we need to annotate all the places which can have null, and only then the compiler will say, hey, you didn't do the null check. So it's very similar. And there is like Kotlin, which said, okay, we don't have nulls.
Yes.
But the problem is that Kotlin uses all the Java libraries. Any one of them can have null.
Yeah.
So it's actually not really
that's
helping, right?
Kotlin will stop you from passing null to a Java library method, but if a Java library method returns a null, Kotlin still needs to check for it.
Exactly.
If you contrast that with, the language that everyone thinks of when you talk about safe these days is Rust.
Yes.
And Rust has no concept of null. It has a union type. I think it's called option. And you can have some which is the value of whatever it is, or none. And with Rust, you can't. You have to check both those branches, otherwise it won't compile. And so that kind of fixes that mistake.
But on the other side, won't you end up with very verbose code checking for null for like everything forever, everywhere, all the time?
You do, but and yeah, it is verbose code and it is more difficult to write, but it works. And at the end of the day, that is the important thing. That's the thing that our customers and our users and our stakeholders care about, is if we push this piece of software onto the cloud or onto somebody's phone or whatever, is it going to crash at any point? And Rust says, no, it's not. Whereas C#, Java, JavaScript, Go, all of these things, if you don't check, then your application, it will just crash. So, that's...
It's a trade-off, I guess. But on the other side, I would still argue that code which is very verbose and kind of full with checks that are not contributing to the business domain that this code is trying to solve, it actually reduces the productivity a lot.
Yes, and that's where I like what they call the empty instance of a class. So, for example, instead of returning null instead of a string, you can return an empty string. Instead of returning null instead of an array, you can return an empty array. And then you're not doing the code. If I return you an empty array and then you do a for or a for each, it will run. It won't do anything, but it will run. If I return null, then you have to say, if the array's not null, then for. And so as much as possible, I like those ideas of empty types.
This is great, unless you really need the third option.
Exactly.
Right, when it's not something, it's not empty, it's just a lack of it.
Yes, that's it. You need a way of saying there isn't one.
Yeah, exactly.
And that's when null comes in.
This is how it was born, basically.
There's
right?
always going to be a use for null. There's always going to be a need for null, a way to say there is no value.
Exactly.
It's like if you have a lady's details in an object and age, and she doesn't want you to know.
Exactly.
And so you can't put 0 because you get babies and they are 0. So you need a way of saying this value doesn't exist. And in those cases, you need to check for it. And that's when these language features like nullable reference types and the annotations are useful.
That's fascinating. This is very interesting stuff. But we could do like the whole another episode on how to avoid the next JavaScript.
Yes.
And I think we do. We still have a lot of time. This is the first day. We have 2 days ahead of us.
Yeah.
If you feel like and you're around, just step in. We'll do another one about how to prevent the next JavaScript from happening.
Yeah, absolutely.
Excellent.
That'd be great.
Mark, thank you very much. It was fascinating. It was very, very interesting. And for all of you folks, stay tuned. You see, that's an amazing content. We will have more of that today, tomorrow, and also on Friday. Stay tuned.